Hi everyone, this is a extension of exponential functions in the graphing. This is going to be based more around transformations, so things like vertical stretching, vertical shrinking, moving the graph left and right, moving the graph up and down, stuff that y'all are already pretty comfortable with that we've already done in class before. So we're just looking at it with an exponential function this time. So we discussed the a value before, we discussed the base. So these two pieces that you see, the a and the b that are here, we've already discussed those in the previous video. Remember that your a value is the same thing as your y-intercept. In this case, it is also going to represent vertical scaling. So if that number in the front is bigger than 1, then you're going to have a vertical stretch, and if it's in between 0 and 1 or smaller than 1, you're going to have a vertical compression. The new piece that we have here is the letter C. So these conditions for C are kind of opposite what you had for A. So if your C value is bigger than 1, that means that you have a horizontal compression. The vertical condition, if A was bigger than 1, you have a vertical stretch, so this is flipped. Something else to note is that these are going to be stretching or compressing by 1 over C. So if you've got, let's say the C value that you see is a 3, 3 is bigger than 1, so that would be a horizontal compression by a factor of 1 over 3. Okay, let's look at the H value. So the H value is going to move you left and right. Remember that X lies, so it's going to move in the opposite direction of what you normally think. The K value on the outside, that's going to move you up or down. That doesn't have any weird rule with it. If it's positive, it goes up. If it's negative, it goes down. Okay, so let's look at the different functions that we've got here. I would recommend using that software that I linked in the Google Classroom to graph these, or if you have Desmos, you can use Desmos to graph it as well. The parent table is going to look different from the transform table. So let's figure out what the parent function is first. Your parent function is always going to be whatever number is in parentheses raised to the x. So my parent function is going to be 2 raised to the x. I don't care about anything else that's around that 2. So to get my parent table, I'm basically going to take 2, I'm going to raise it to the negative 1. 2 to the 0, 2 to the 1, 2 squared. So I get 1/2, 1, 2, and 4. So let's go ahead and graph that. I'll do that one in red. Okay, so that's our original parent graph. And then let's do the transform table in blue. So the transform table, I'm going to use, I'll just use the same x values that I had before. And then you can either put this in the calculator or you can do it in your head. Basically what you're going to be doing is taking this x value and plugging it in for the x that's in your equation right there. So the values you should get are -2, -1, 1, and 5. Let's go ahead and graph that one. Okay, so that is what our graph looks like. Something to note here, let's go ahead and look at the asymptote of the transform function, so the blue one. The asymptote on the blue graph is right here, and the y value of that line is -3. Notice that here, the -3 in the back, this is representing your horizontal asymptote. So my horizontal asymptote is at y equals -3, and that's coming from the -3 that's in the back of your equation, okay? So the transformations that are being applied to from the red curve to the blue curve, I've got the number 4 in front. That number 4 in the front is going to be a vertical stretch. And that's because of the 4 in the front. Then I've got the base of 2. The base of 2 is not transforming the function at all. It's just telling me what the parent function is. So that 2 in parentheses is not doing anything to your graph, okay? Then I've got this -1 up in the exponent. That is going to move me right 1. So remember that x lies. Normally I think that minus goes left, but in this case it's going to go right. So the right 1 is because of the -1 that you see up in the exponent. Then I'm going to move down 3, and that's because of the -3 that's in the back. So my original asymptote on the red curve was at 0 here, and I've moved that asymptote down 3 now, so that's why it's at -3. Okay, my domain and my range. So remember, we're talking about the domain and the range for the blue transformed function. So let's look at that. Your domain is still going to be all real numbers. I can still plug in any number that I want to in this function. So I'm going to go -infinity to +infinity. I've got arrows on both ends of my graph. Now let's look at the range. So for the range, you're looking from the bottom of the graph to the top of the graph, paying attention to the blue curve. So notice that the asymptote is now at -3. It's no longer at 0. So my new range is going to go from parenthesis -3 to infinity. So instead of starting at 0, now the bottom of my graph is going to be at -3. Okay, on these, the next two, I am going to go ahead and fill out the tables really quickly using my calculator. So the video is going to like pause for a second, and then it's going to go right into me having the tables filled out, but I'm just doing it on the calculator. Okay, so I've got my tables filled in and I've got my equations graphed. Let's take a look at my parent table really quickly. So again, just to remind you, your parent function is just whatever number was in parentheses, so the 1/2 raised to the x. So that's what I graphed in red. The transformed is the entire equation that's up here, and I'm just replacing those x values with the x that's in the exponent and then calculating and getting that number. So our new asymptote for the blue line, notice that -4 that's in the back. Remember, that's your horizontal asymptote. And then also here, that's kind of where my graph is starting to taper off. Okay, so our asymptote is now at y equals -4. The transformations are, let's look, I've got a 3 in the front. So the 3 that's in the front is going to be a vertical stretch. The 1/2 in parentheses is not doing anything to the graph. That's part of my parent function. The -1 up in the exponent is going to move me right 1 because x lies. And then the -4 in the back is going to move me down 4. My domain is always going to be the same, -infinity to +infinity. And then the range is going to depend on the asymptote. So my asymptote is at -4. That means that the lowest my graph is going to go is -4. And then I'm going to go to infinity, all the positive y values above that. Okay, now let's take a look at this third one. So my parent function here is going to be 3 raised to the x. So go ahead, take a minute, fill out your table, and graph the original and the transformed functions. All right, so that is what your table and your graph should look like. So let's talk about the transformations now. So notice that your graph on this one, the blue graph, is now flipped from what the red graph was, and it's been flipped over the x-axis. The reason that's happening is because the negative sign that you have in the front here, that is a reflection over the x-axis, so it's causing your graph to flip. So instead of being a growth now, it's going to be decaying this time. My asymptote here is still at y equals 0, so it's still getting very, very close to that y value of 0. My transformations, I know that the negative sign in the front is causing me to reflect over the x-axis. That minus in the front. And then I'm going to be moving to the right 2 because of that -2 that's up in the exponent. Okay, so all the all of my values are getting shifted to the right by 2. My domain here, I'm still looking at all real numbers. I can still input whatever number I want to into my function. The range here is a little bit tricky now because the graph is no longer increasing from left to right, it's decreasing from left to right. So as I'm reading the graph from the bottom to the top, the bottom of the graph is not at 0. The bottom of the graph, this arrow that's here, it's pointing down to negative infinity. So my range is going to start at negative infinity, and then I'm going to keep crawling and crawling and crawling to the top, and eventually the number that I'm going to get to is 0. So that y value of the blue curve gets very, very close to 0, but it doesn't touch it, so I'm going to put a parenthesis. So when your graph is flipped over the x-axis, now I'm moving from my range of negative infinity, because that's the bottom, up to the top of the blue curve, which is now at the y value of 0. Okay, our last little extension portion here is going to be looking at the number e. E is also called Euler's number. This is very similar to pi. Pi is just a special number and we gave a name to it. Euler's number is very similar to that. There are many different ways that you can derive it. We're just going to kind of be doing it by graphing here. So Euler's number is approximately 2.718. If you want to type this in your calculator and graph it, you can. If you graph it on your calculator, it's going to look something like this. And if I type in for x, if I substitute x with 1, then the number I get back is 2.718, which is e to the first power, or Euler's number. It is an irrational number, so you can't write it as a simple fraction. It's going to continue on forever. And it is the base of natural logarithms. We're going to get into logarithms in a different unit, but just know that you're going to see it again. We're just kind of introducing it to you right now. The asymptote is here. That's happening at y equals 0. My domain is negative infinity to positive infinity. And then my range is going to go from 0 to infinity. So it shares a lot of those same properties as the other exponential functions that we looked at. So I'm going to do transformations on it. So notice that my parent function here, the number that is in parentheses is e. So my parent function is e raised to the x. So e is not a variable. It's not something that's going to be changing. It's like pi. It's just like a number. Okay, so for my parent table, I am going to substitute, so e to the negative 1. I'm just going to round these numbers. I went ahead and graphed my parent function in blue and then the transformed one in red. The transformed one looks a little funky and I had to pull some weird numbers just so I could find stuff that actually fits on the graph. But overall, generally, the graphing rules are the same. So your asymptote here, notice I've got that green dotted line. That's going to be at y equals negative 5, and I know where it is because of the minus 5 that's in the back of my function. My transformations, I've got the number 2 that's in the front of everything. That is going to be a vertical stretch. I've got the e in parentheses. Remember, that's not doing anything. That's just part of the parent function. Then I've got the plus 4 up in the exponent. That is going to move me left 4 because x lies. And then I've got the minus 5 in the back. That's going to move me down 5. Okay, my domain here is the same. I'm still looking at all real numbers. And my range is going to depend on the asymptote. So my asymptote here is at negative 5. And then I'm going to go to all the positive y values above that, so up to infinity. That concludes our video lesson over exponential transformations. If you have any questions, please email your teacher.